Go blue. All right, so tonight I want you to go ahead and open up your textbook to page 746. We're going to do a little bit of work with roots. So go ahead and pause this video and open it to 746. Okay, so up till now we've been talking about the roots of a quadratic equation. We should know that quadratic equations make parabolas, and its roots are the x-intercepts of the quadratic equation. And most of our equations have been in this, which is standard form. And hopefully you've been paying some attention here, because when it's in standard form, this is the c, the constant, and it gives you the y-intercept. So already we know that this parabola will cross the y at 0, 12. So we know what the y-intercept is, but we want to figure out what its roots are. And so we're going to treat this like we've been doing earlier, where we're just going to look at this equation and we're going to factor it to put it into intercept form. And most of you have liked using this chart. So again, we take our x squared and put it in this box here. And we take our constant, which is 12, and put it in here. And then we have to figure out what times what will give us x squared. And we know that x times x gives us x squared. Then we have to figure out, well, what will multiply to 12, but it's also going to have to add to a negative 8. In order for that to be negative and this to be positive, these two numbers are going to have to be negative, because a negative times a negative is a positive. And so we have to think about what two negative numbers will add to negative 8 but multiply to positive 12. So we think about that, that's probably going to be 6 and 2. Negative 2 times negative 6 is positive 12. And then here we have negative 6 times x, that's negative 6x. And here we have x times negative 2, that's negative 2x. And then if we take this and add our middle terms together here, the like terms, that gives me negative 8x. So I know I've done that right. So I know that my intercept form is going to be x minus 6 and then times x minus 2. And we're going to set that equal to 0. So we've sort of done this already. We've already said when it's in intercept form, these are the x-intercepts. In this case, I just want you to set them equal to 0, which may help some of you that are having a hard time finding the x-intercepts in the first place. So we take each set and separately set it equal to 0. So we take x minus 6 equals 0. And then we take x minus 2 and set it equal to 0. And then again, you would just solve. So we add 6 here, and we add 6 here. And so we know x is equal to 6. And then to solve for x here, we would add 2 and add 2 here. And so that would tell me that x equals 2. So there we know that our roots are going to be at 6 and 0 and 2 and 0. Okay, so if I were to, graph this, I would know that, let's see, this would be at 2, cross right here, and 1, 3, 4, 5, 6. So my roots would be cross through the x-intercepts here, and then the x-intercepts here. And so my quadratic equation is going to go through those 2 points. Now remember, when we did the roots equation, it was x minus r1 in parentheses, and then this was x minus r2. And you can see that 6 is in the r1 place and 2 is in the r2 place. 6 and 2, or you can set them equal to 0 and solve for that way also. Also, you can check and see. It says check your solutions to see if this is correct. So what I can do is I want to go back to my original equation here and plug that in. So let's look at the 2. If I plug in 2 for x, I'll get 2 squared minus 8 times 2 plus 12 equals 0. So I know this is going to give me 4. This is going to give me 16. And then plus 12. Does that equal 0? So 4 minus 16 is negative 12. Negative 12 plus 12 is 0. So I know that the 2 is correct. And then I can do the same thing with the 6. I can plug in here. I get 6 squared minus 48, which would be negative 12 plus 12 equals 0. So you can check and see if those are correct. So I want you to go ahead and pause the video and complete number 4 on your own, and 5, and then we'll come back and do 6 together. So looking at 6, we have ax squared plus bx, but there's no c. It's missing its c value. So what we need to do in this case is just factor it. So I want to look at what will go into x squared and what will go into 11x. And we can divide x into both. So we're just going to factor this by dividing by x. That's the greatest common factor. So I bring x out front. And then x squared over x to the 1, 2 minus 1, that will just give you x. We'll bring the minus down here. Those x's cross off and gives you 11. So in this case, we'll have x equals 11, x minus 11 equals 0. And then again, we're just going to factor that out. We're going to set each part equal to 0. So we're going to set x equals to 0, which means x could be 0. And then we're going to set x minus 11 equal to 0. And then if we solve for that, we'll just add 11 over. So here x will equal 11. So my 2 roots here are going to be, it's going to go 0, 0. So it's going to go through the origin, and then this will be 11, 0. So my parabola is going to go through 0 and 11. So if we look down here at this one, now we have x squared plus 8x equals negative 7. So you want to get that in the equals to 0 format. So all I'm going to do is I'm going to add this 7 over. Now it's not a like term with 8x, so I'm just going to make this x squared plus 8x plus 7 equals 0. And then this one should be pretty easy. You can use the box method, you can use the t-chart, but as you start doing these, you should be able to get to the point where I'm looking at the factors of 7 that are going to add to the middle number. The only factors of 7 are 7 and 1, and 7 plus 1 is 8. So this one I could very simply just say x plus 1, and it's going to be x plus 7 equals 0 without doing all that work, because it's an easy problem. There's only 2 factors of 7. 7x, or 1 times 7 is 7, and then 1x and 7x will give you 8x. And then again, just set these equal to 0. So I have x plus 1 equals 0, and then we're just going to subtract the 1. So the root is going to be negative 1, and then we'll have x plus 7 equals 0, and subtract the 7. And so in this case, the other root is going to be negative 7. Now, if you're good, you can start looking at this. We've kind of talked about this before. We said that the intercepts formula is x minus r1 and then x minus r2. And you can see this says plus 1, but it's supposed to be minus 1. So it had to be a negative negative to make this a plus. Or as we've talked about, it's the opposite of what you see here. It's plus 1, so it's going to be minus 1. It's plus 7, it's going to be minus 7. And that follows with what we did, because you have to subtract the 1 over to solve for the x and subtract the 7 over to solve for the x. So you should be able to start shortcutting some of these. The last one here, you want to do the same way. But again, you have to subtract it over so that you have it equal to 0. So again, here we have a like term. That's minus 13x, and I can do it with this like term here, minus 13x. So that's going to give me x squared minus 18x. And then there's no like term with the 81, so I just want to add that over. So it'd be plus 81 equals 0. So go ahead and finish solving that on your own. Get it into the slope-intercept form and identify the roots. And then this last one gets a little trickier because if you'll notice, this one has a coefficient of 3. And up till now, we've only had coefficients of 1. So we're going to use our box method again, as we've done on previous problems here. And so again, we want to take that 3x squared and put it in here. And then again, we want our constant to be here. And that's multiply. So I think what two things multiply to 3x squared? Where there's only two things, x times 3x squared give you 3x squared. So now we have to, it's a little bit trickier because now we have to figure out what's going to go here. And if you look, it's got to add to a negative number but multiply to a positive. So again, that should tell you that these two numbers have to be two negatives to multiply to a positive 7. And again, there's only two factors that will work, 1 and 7. So let's plug them in and try. Negative 1 and 7. So I'll have negative 1x here and negative 21x. I realized I made an error here. This shouldn't be x squared because that would make it x cubed. It should just be x, right? So that's 3x times x is 3x squared, right? So then if I look here and add these up, negative 21x and negative 1x would give me a negative 22x. And then is that what I need? Yeah, I needed a negative 22x. So again, now I'm just going to write these. 3x minus 1 times x minus 7 equals 0. And then again, you need to set each one of these to equal to 0 and solve for x. And I want you to do that on your own. Set 3x minus 1 equal to 0 and solve for x. And then x minus 7 equal to 0 and solve for x and identify your two roots. And we will be cheering for the blue tonight. Go Blue and Maize. NCAA championships. Let's go. Finish your homework tonight.